Okay, welcome guys. In many cases, mm, we can use a reasonable argument which is based on basically symmetry to calculate center of mass. Okay, to calculate center of mass. Okay, guys. In if an object has a spherical symmetry. Okay, if an object has a spherical symmetry, here the you know you should know what is the meaning of a spherical symmetry. Okay, a spherical symmetry, a spherical symmetry. Okay, guys, if an object has a spherical symmetry, then uh, its center of mass will be the center of a sphere. Okay, and we can decide it by simple argument. Okay, by simple mathematical argument with the help of geometry and okay and algebra. Okay, we can decide that center will be the in you know center of mass will be the center of the sphere. Okay, and here if I say that it has a spherical symmetry, it does not mean that the mass is distribution is mass is uniform. Okay, a spherical symmetry is does not mean that it has uniform mass distribution. Okay, guys, a spherical symmetry means that distribution of mass is a spherical. Okay, for example, if you look at this, here this is a sphere, this is a sphere of mass m. Okay, guys, so its center will be here in which the mass is uniformly distributed. So here center will be a center of mass, we know this center of this sphere. Here suppose here this is a it has an hollow sphere. Okay, it has an hollow sphere. So guys, here the mass is distributed only along this region, only in this region, only in this region. Here there is no mass. So where is the center? Where is the center? Guys, here center will be at this, you know this this will be the center. Okay, this point will be the center of mass. Okay, the spherical center of this hollow sphere will be the center of mass. Okay, guys. Okay, the this will be the center of mass. So here if you look at this mass distribution, here between from center to this there is no mass, you know and after that you find mass. Okay, guys, so here mass is not uniformly distributed, but center is, but the distribution of mass has an spherical symmetry. Okay, here you should note here that mass is mass is not uniformly distributed. Okay, not uniformly distributed. Okay, distributed, but it has, but mass has. Okay, but it has mass distribution, but it has a spherical symmetry. Okay, a spherical symmetry. Okay, guys, similarly we can calculate, we can by argument of geometry, argument of symmetry, we will see that the center of mass, a material which has cylindrical symmetry. Again, here symmetrical symmetry does not mean that uniform distribution of mass. Mass distribution should be cylindrical in manner. Okay, okay, mass distribution should be in cylindrical in manner. Okay, guys, so here if if any if any system has cylindrical symmetry, mass distribution is cylindrical in manner, then its center of mass will going to lie along the axis of this cylinder. Okay, the center of mass will be along the axis of this cylinder. Okay, and similarly, if if mass distribution is in planar way manner, then the center of the plane, for example, here look here, the center of mass will be this. If you assume that mass distributed only between them and this mass is uniformly distribution, so here mass distribution is in planar symmetrical manner. Okay guys, so here this center of mass will be this point will be the center of mass. Okay, so it is quite reasonable to use the argument of geometry and symmetry to find center of mass. Okay, thanks for watching.